My AI agent tried to issue a refund. Tool not found. Claude connected to my Spring Boot service. I could see the handshake in the logs, but when it called issue refund, the response came back empty. No tool registered. No method exposed. The agent saw nothing callable in my entire application. I had 14 endpoints. A full order service with check status, issue refund, cancel order. But from the agent's perspective, my backend did not exist. This is MCP Server with Spring Boot on rendered the code. After building 3 production AI integrations, by the end of this video, you will have a working MCP server that exposes your existing service methods as callable tools. Let me show you why this happens. Before MCP, my order service lived behind a REST controller. Clients called HTTP endpoints, but AI agents, Claude, Cursor, Copilot, they do not call REST endpoints, they call tools. A tool has a name, a description, and a parameter schema. The agent decides which tool to invoke based on the user's intent. Without an MCP server translating between the protocol and your code, the agent has no catalog to browse. It cannot discover your methods. In any backend architecture, this is the missing bridge, a standardized protocol that connects large language model tool calls to your existing business logic. I spent 2 days building a custom JSON RPC wrapper before discovering Spring AI already handles this. One annotation. If this sounds useful, hit like. AI agents do not call REST endpoints. They need an MCP server that translates tool calls into method invocations on your service layer, and without it, your backend is invisible to every agent that connects. One annotation exposes your method. The tool annotation from Spring AI takes a name and a description. You place it directly on your existing service method. No new controller, no wrapper class, no protocol handling. When the Spring AI MCP boot starter initializes, it scans every bean for tool annotated methods. Each one becomes a callable tool in the MCP catalog. The agent receives the tool name, the description you wrote, and the parameter schema inferred from your method signature. On the caller side, Claude or Cursor connects to your MCP endpoint. It requests the tool list. Your issue refund method appears with its order ID parameter and the description you provided. The agent matches the user's intent to your tool name. It calls issue refund with the order ID it extracted from the conversation. Your method executes. The return value goes back through the protocol to the agent. Pause and think. How many of your existing service methods could become AI callable tools without changing a single line of business logic? The answer is all of them. Between your service layer and the MCP protocol, the Spring AI starter handles serialization, parameter mapping, and response formatting. During execution of a tool call, the framework deserializes the agent's JSON parameters into your method's argument types. It invokes the method on the Spring managed bean. It serializes the return value back to MCP response format. Your issue refund method does not know. It was called by an AI agent. It runs the same code path as if a controller called it. I post production tutorials like this every week. Subscribe if you want to catch the next one. The tool annotation turns any Spring Bean method into an MCP callable tool. No new endpoint, no protocol code. Your service layer becomes the AI integration surface directly. But here is where production breaks it. My MCP server worked on localhost. One instance, one agent. Perfect. Then I deployed behind our API gateway with 2 replicas. The agent connected to replica A. First tool call succeeded. Second call routed to replica B. Tool not found. The session state lived on replica A. Replica B had never seen the handshake. No error in my logs. The agent simply received an empty tool catalog from a server that did not recognize it. At the integration boundary between your gateway and your MCP replicas, session affinity determines whether the agent can even see your tools after the first call. The default transport, service and events requires a persistent connection. A load balancer that routes the follow-up request to a different replica kills the session silently. The agent retrieves, gets routed to a third replica. Fails again. 3 attempts. 0 tools found. From the consumer's perspective, your MCP server is unreachable despite all replicas being healthy. The fix is the new stateless HTTP transport released in the MCP specification update of 2026. Inside the implementation, you switch the transport config from C to HTTP streamable. Each request carries all context in headers, no server-side session needed. Your gateway routes to any replica. The agent sends a session identifier in the MCP session ID header. Your replicas validate the session against a shared ready store instead of local memory. Both replicas now serve any tune call regardless of which one handled the initial connection. Production MCP servers must use stateless HTTP transport. SSE requires sticky sessions that break behind load balancers, and a disconnected agent feigns silently against a replica that never saw the handshake. We fixed the transport, but there is one scenario that terrifies me. An agent calling issue, refund in a loop, no human approval, no rate limit, 12 refunds in 4 seconds. That is what an unsecured MCP server allows. Every tool is a method invocation with parameters chosen entirely by the AI. The hardened version starts at the entry point, your MCP security config, validates the authorization header before any tool dispatch reaches your service layer. The agent must present a valid bearer token. Without it, the connection drops before the tool catalog is even returned. Further downstream in your configuration, each tool maps to a required scope. The issue refund tool requires admin scope. The check status tool requires read scope. An agent with a read-only token can browse order status but cannot trigger financial operations. Quick recap. 1. Bearer token validates the agent's identity. 2. Tool level scopes restrict what each token can call. 3. Rate limiting caps invocations at 10 per minute per session. Got it? Now here is what this means in production. When the next agent hallucination happens, and the rate limiter returns 429 after the 10th call. The agent receives a structured error telling it to wait. Your issue, refund method never fires the 11th time. 0 runaway refunds. We connected AI agents to our Spring Boot service. But there is a deeper problem, observability. When an agent calls your tools at 2 in the morning and something breaks, how do you trace which tool was called? With what parameters? By which agent? That is the next video. An unsecured MCP server is a remote code execution endpoint without auth and rate limits. One hallucinating agent loop exhausts your business logic in seconds. Thank you for watching. Like, subscribe, and drop your answer in the comments.